All right. So to bring us to what we're going to dwell on today. All right, so we're going to be talking about the physiology of nerve transmission, the function of nerve transmission, how a nerve transmits an impulse. All right, we've already defined parts of the neuron that include dendrites, the short, numerous processes that receive incoming information. Information coming from other neurons and coming in to influence the firing of the neuron of interest, okay? Whereas a neuron has many of these short, numerous processes called dendrites, so that they can receive incoming information from many directions, many other neurons. Each neuron has just one axon that sends an impulse away from the nerve cell body to some other type of cell, okay? We're interested in how the nerve signals are sent. And the nerve signals are sent by an electrochemical impulse. The electrical part of the nerve impulse will occur whenever signals are traveling within the nerve cell processes or nerve cell body. Okay, so we're going to be interested in the electrical changes that happen. And so as long as the signal or impulse is traveling anywhere in the nerve cell body, even incoming signals, okay, electrical processes will be involved. Along the axon, the transmission of an electrical signal called the action potential.
Does it start at the dendrites, then go work its way down?
Yes, that's one way that information comes in. A lot of information comes in from other neurons by way of the dendrites. And then their information, their signal, will be directed always toward the nerve cell body. And then from there, the signal, if it's going to continue, all of the incoming signals will try to initiate a signal at the very beginning of the axon. The axon is how a nerve cell sends a signal away from its body to some other cell. Either some other cell that's another neuron, or some other cell that's going to be a muscle cell, and that's how nerve cells stimulate muscles to contract, or some other cell will be a gland, where nerve cells stimulate glands to secrete. Okay, but we're interested in the electrical changes that represent that signal, that nerve impulse traveling. As long as the impulse is traveling within a neuron, that nerve impulse will travel by electrical changes that we're going to understand by looking at this discussion. But once a nerve cell attempts to continue its signal to another cell, almost always, not quite always, but in most cases, there will be a junction in which there's a space between the ends of the axons of one neuron versus the next neuron or the next cell. The electrical changes cannot jump across that space called a synapse. The junction is a synapse. And we'll look more closely at the space in just a minute, but I want to give you the overall picture first.